Didn't hit stop on that previous video. I wonder if anybody's going to catch that. Here's the Washington Monument problem. I'm not going to show you any of the answers because I think the numbers don't change, but here's a couple of the setup things to help you out. Here's the diagram they give you. They tell you in the verbiage that cosecant is equal to 1.1. Well, that doesn't help us right away. We need to find out what this angle is so we can figure out what the slant range and how long the shadow is. So remember, we have to remember that cosecant is the reciprocal of sine. So if the cosecant is 1.1, then sine is 1 over that value. Because what's the reciprocal of 1.1? 1.1 is written as 1.1 over 1. So if we take the sine inverse of that in our calculators, and let's make it in degrees for this problem, if I didn't say that before, then you will find out what theta equals. The answer's underneath here. Then the next part of the problem, you need theta right there to figure out with the sine function what is the slant range from where you are to the top of the monument. So you'd set up sine of theta is 555 over that d, right? So I expect by this point you guys should be able to manipulate this and solve for d. That's going to be a distance right there. And then lastly, they ask you what the L is, the length of the shadow. This is just like the Talisa shadow problem from the tests we just took. So this one in tangent, 555 over L, and then you have to use that theta again and correctly do the manipulation in the calculator to solve for L. That's it. Let me hit stop this time.